In general, we can use the empirical count of events in the observed data to estimate the probabilities. And a commonly used technique is called a maximum likelihood estimate, where we simply normalize the observed count. So if we do that, we can compute these probabilities as follows. For estimating the probability that we see a word occurring in a segment, we simply normalize the count of segments that contain this word. So let's first take a look at the data here. On the right side, you see I listed some hypothesized data. These are segments. And in some segments, you see both words occurred. They are indicated as ones for both columns. In some other cases, only one word occurred. So only that column has 1 and the other column has 0. And of course, in some other cases, none of the words occurred. So they are both zeros. And for estimating these probabilities, we simply need to collect the 3 counts. So the 3 counts are first, the count of W1, and that's the total number of segments that contain word W1. It's just the ones in the column of W1. We can just count how many ones we have seen there. The second count is for word 2, and we just count the ones in the second column. And this would give us the total number of segments that contain W2. The third count is when both words occurred. So this time we're going to count the segments where both columns have ones. And then so this would give us the total number of segments where we have seen both W1 and W2. Once we have these counts, we can just normalize these counts by n, which is the total number of segments. And this will give us the probabilities that we need to compute the mutual information. Now, there is a small problem when we have 0 counts sometimes. And in this case, we don't want a 0 probability because our data may be a small sample, and in general, we would believe that it's potentially possible for a word to occur in any context. So to address this problem, we can use a technique called smoothing, and that's basically to add some small constant to these counts, and so that we don't get a 0 probability in any case. Now, the best way to understand smoothing is to imagine that we actually observed more data than we actually have. So we pretend we observed some pseudo segments that are illustrated on the top, on the right side on the slide. And these pseudo segments would contribute additional counts of these words so that no event will have 0 probability. Now, in particular, we introduced the 4 pseudo segments. Each is weighted 1/4. And these represent the 4 different combinations of occurrences of these words. So now each event, each combination will have at least 1 count, or at least a non-zero count from these pseudo segment. So in the actual segments that we observed, it's okay if we haven't observed all the combinations. So more specifically, you can see the 0.5 here actually comes from the 2 ones in the 2 pseudo segments. Because each is weighted 1/4, we add them up, we get 0.5. And similarly, this 0.05 comes from 1 single pseudo segment that indicates the 2 words occurred together. And of course, in the denominator, we add the total number of pseudo segments that we added. In this case, we added 4 pseudo segments. Each is weighted 1/4. So the sum is actually 1. So that's why in the denominator, you see a 1 there. So this basically concludes the discussion of how to compute the mutual information, how to use this for syntagmatic relation discovery. Now, so to summarize, syntagmatic relation can generally be discovered by measuring correlations between occurrences of 2 words. We introduced the 3 concepts from information theory: entropy, which measures the uncertainty of a random variable x; conditional entropy, which measures the entropy of x given we know y; and mutual information of x and y, which measures the entropy reduction of x due to knowing y. or entropy reduction of y due to knowing x. They are the same. So these three concepts are actually very useful for other applications as well. That's why we spend some time to explain this in detail. But in particular, they are also very useful for discovering syntagmatic relations. In particular, mutual information is a principled way for discovering such a relation. It allows us to have values computed on different pairs of words that are comparable. And so we can rank these pairs and discover the strongest syntagmatic relations from a collection of documents. Now note that there is some relation between syntagmatic relation discovery and the paradigmatic relation discovery. So we already discussed the possibility of using BM25 to achieve weighting for terms in the context to potentially also suggest the candidates that have syntagmatic relations with the candidate word. But here, once we use mutual information to discover syntagmatic relations, we can also represent the context with this mutual information as weights. So this would give us another way to represent the context of a word, like a cat. And if we do the same for all the words, then we can cluster these words or compute the similarity between these words based on their context similarity. So this provides yet another way to do term weighting for paradigmatic relation discovery. And so to summarize this whole part about word association mining, we introduced two basic associations called paradigmatic and syntagmatic relations. These are fairly general. They can be applied to any items in any language. So the units don't have to be words. They can be phrases or entities. We introduced multiple statistical approaches for discovering them, mainly showing that pure statistical approaches are feasible, are available for discovering both kinds of relations, and they can be combined to perform joint analysis as well. These approaches can be applied to any text with no human effort, and mostly because they are based on counting of words. Yet they can actually discover interesting relations of words. We can also use different ways to define context and segment, and this would lead to some interesting variations of applications. For example, the context can be very narrow, like a few words around a word, or a sentence, or maybe paragraphs. And using different contexts would allow us to discover different flavors of paradigmatic relations. And similarly, counting co-occurrences using, let's say, mutual information to discover syntagmatic relations. We also have to define the segment, and the segment can be defined as a narrow text window or a longer text article. And this would give us different kinds of associations. These discovery associations can support many other applications in both information retrieval and text data mining. So here are some recommended readings. If you want to know more about the topic, the first is a book with a chapter on collocations, which is quite relevant to the topic of these lectures. The second is an article about using various statistical measures to discover lexical atoms. Those are phrases that are non-compositional. Or, for example, hot dog is not really a dog that's hot. Blue chip is not a chip that's blue. And the paper has a discussion about some techniques for discovering such phrases. The third one is a new paper on a unified way to discover both paradigmatic relation and syntagmatic relations using random walks on word graphs.